Okay, we're going to take a look at this example problem on how to solve systems of equations with three variables, as you can see here. Now, I've got my three equations here with pretty big numbers. So this is a fairly difficult problem because the size of the numbers I'm going to be multiplying and working on here. The first thing that you want to do is you want to work with two different equations here, and I'll call them 1, 2, and 3. I want to work with any combination of these to eliminate one variable. The first decision you have to make is which variable would be easiest to eliminate. And you got to be very selective here, because if I were to say eliminate y by doubling equation 2 and subtracting it from equation 1, that would work. If I double 2, I could get the 5y here to turn into a positive 10y, and when I add it to 10y, the y's would go away. That would work. But then there's nothing I can really do with equation 3, either in combination with equation 2 or in combination with equation 1, where I could only multiply one equation. And that's what I'm looking for. I don't want to multiply two equations to get something to cancel. I only want to multiply one. So I'm going to forego the y's. If I look at the x's, nothing here looks like it's going to line up. I could multiply this equation, equation 2, by a 3, and I could multiply this equation by a 2, and then those would cancel. I could do the same by multiplying this by 7 and this by a 2. I could do combinations like that, but none of those look like they're going to be real easy. I actually think that if I double the bottom equation, or multiply it by -2 and work it with the top equation, I'll get z's to cancel. And then I can also triple the bottom equation and get it to cancel with this 12z here. So I'm actually going to work the z's. I hope you see why I chose that, because to get my other two equations, right, that's what I'm after. I'm over here, I'm seeking two new equations with only x and y. That's what I'm after here. I think I can do that with the least amount of math possible. Now, there's still lots of algebra to do, but I think I can do it here. Okay, so first of all, I'm going to take this bottom equation, number 3, and I'm going to multiply it by a -3 to try to get it to cancel with this 12z. Okay, so I'm going to go -3. I'm going to take this whole equation here. I'm going to multiply it by a -3, and let's see what I get. I'll write it out down here. Okay, -3 times a 3x is going to give me a -9x. -3 times the +4y is going to give me a -12y. -3 times the +4z is going to give me a -12z. And I write my z's like this to make sure it doesn't look like a 2. And a -3 times a 26 is going to give me a I believe that's going to be a 78, -78. There's one equation that'll work. And now I'm just going to rewrite equation 2 right down here. Equation 2, just to make sure I'd make no mistakes, I'm going to write equation 2 down here. -5y plus 12z, and this is what I wanted here, was I want to cancel those z's, equals -90. So we got some math to do here, but clearly this is what I'm after. I'm going to get 0 z's here, so these just go away. Okay, that's what I want. -9 minus 2 gives me a -11x, -12 and 5 gives me a -17y, a -78 and a -90, I believe, give me a -168. And yes, I've used a calculator on this. Don't feel bad if you got to do that yourself. Okay, to get rid of this, I'm just going to erase this z factor here. And here's one of my two equations, right? Oops. I wanted one equation with only x and y. There's one of them right there. Okay, I'm going to call it equation A for now. All right, now remember, my strategy here was to come up here, and now I think I can do the same thing with this bottom equation, but this time, to cancel it with this 8z, I'm going to multiply it by a -2. So let's erase this -3. I'm going to try to get it with a -2, okay, times this whole thing here. All right, so this looks a little bit messy, but I think you can follow along, okay? -2 times the 3x gives me a -6x. Okay, -2 times the 4y gives me a -8y. A -2 times the 4z gives me a -8z, and that's what I'm after. Okay, I want that -8z. -2 times 26 gives me a -52, I believe, if my math is correct. Okay, so now let's scroll up and let's look. Equation 1 here, I'm going to rewrite down below. I'm going to write it all the way down here. Keep going. Okay, I'm just going to rewrite it down here. Okay, and so equation 1 was 7x minus 10y plus 8z, and there's my key combo, the 8z and the minus 8z. This is a minus 50. Okay, so now I'm going to add these two equations, and this is what I want to happen. That gives me 0z, so those go away. Okay, that's what I want. 7x minus 6x gives me a 1x. Minus 10y minus 8y gives me a minus 18y. And a minus 52 and a minus 50 give me a minus 102. There I go. Okay, if you can follow my writing, that looks pretty good. Now I've got a second equation, equation B. If I get rid of this y, which is 0y, now I've got two equations here that actually I can now work to get my final solution. Okay, don't worry about this B, that's just a label. Okay, so once again, notice how I did that. I strategically planned on canceling the z's because each time I only had to multiply one equation, turns out it was this bottom one, by a minus 3 to get this, then by a minus 2, oops, to get this one here. And that made my z's cancel. I now have equation A and B that I can use to solve, just like you've learned before, a system of equations with just two variables. It gets considerably easier here. Okay, so just to be safe here, let's take this top equation here and let's rewrite it down below. Here we're going to do this, and I'm going to rewrite the equation here, minus 11x minus 17y equals minus 168. Okay, now I've got to solve these two equations here to try to get a solution. I'm going to try something different here. This top equation, B, actually looks like I could use that for substitution. So I'm just going to rewrite x equals minus 102. I'm going to move this 18y over to the other side, plus 18y. And now I've got x in terms of only y. I can plug it in right there and solve that for the whole equation. Okay, so minus 11 times x. And I plug this whole thing in here. Every time I see an x, I just plug it in. Minus 102 plus 18y. And don't forget the rest of the equation. Minus 17y equals minus 168. Okay, so I've got a whole equation here. Now I got some math to do. Okay, minus 11 times minus 102 gives me, I think, an 1122. And of course, we're using a calculator for that. Okay, that's what these two gave me. Now, minus 11 and 18 gives me a minus 198y. But I've still got this minus 17y out here equals minus 168. Okay, combine like terms, 198 minus 17, I believe that gives me a minus 215 times y. Okay, if I move the 1122 and move it over here to this side of the equation, it will become a minus 1122 minus 168. If you add those two numbers and make sure they're negative, I believe you get a minus 1290, if my math is correct. And so all I need to do now is divide both sides of the equation by 215, or negative 215. And so when I do that, I get minus 1290 divided by minus 215, and it turns out to be 6. If you were to get some crazy decimal answer here, like 14.256, probably a sign that you're not doing it correctly. When I get y equals 6, clearly that's a nice even number, and this problem was designed to work out even smoothly for you. So that is a sign that you're doing it correctly. Now, what do I do with the y? Okay, let's double check. I want to go back up here. I want to take that y and plug it into my equation for x up here. Let's scroll up a little bit, and it's minus 102 plus 18y. Okay, so x equals, let's just rewrite it down here, minus 102 plus 18y, and I just plug in 6 for y. So I'm just going to figure x out this way. I'm going to go minus 102 plus 18 times 6, because that's what y is, right? Plug it in right here. Okay, and that turns out to give me, I believe x is 108. It's a minus 102 plus 108 if I do the math. And guess what? 108 minus 102 gives me 6. X also equals 6. So another sign that we're doing it correct. Now, which of these top equations, okay, I'll use the bottom one because the numbers are lowest. I like the 4, 4, and 3 as opposed to 7s, 10s, and 12s, and 90s. Okay, so I'm going to take that, and I'm just going to rewrite that bottom equation and plug in both x and y, which are both 6, into that bottom equation. It was 3x plus 4y plus 4z equals 26. And now I'm just going to plug in those 6's. 4 times 6 for y, 3 times 6 for x, plus 4z equals 26. And we're going to solve for the only thing we don't know, which is z. Okay, so here we go. Looks like I'm out of space, so this is going to be an 18 plus a 24 plus a 4z equals 26. You can forget about this thing. It's not a minus sign. Better erase it. Okay, and what this means is 18 and 24 give me 42. When I subtract 42, I'm going to have to go up here because I'm out of space on this page. Okay, when I subtract 24 or the 42 from the 26, I believe I'm going to get a 4z equals a 26 minus 42, which is minus 16. And then when I solve for z, I'm going to get minus 16 divided by 4, which is minus 4. So z turns out to be a nice clean whole number as well. My final answer is x equals 6, y equals 6, z equals minus 4. And that is how you solve these problems. Here is your final answer. It is this tripled pair, 6, 6, minus 4. Okay, I hope that is clear on how to do systems of equations with 3 variables. The key, once again, is in deciding which formulas or which of the 2 equations you cancel. But either ones you choose, you should be able to get these answers. It's just that I think there's a little bit more work if you chose to cancel x's or y's based on these specific equations.